Welcome to Pavinar's webinars for the pavement community. My name is Andrew Bram, and today we'll be talking about innovative pavement techniques and products. Now, before we get started, I would like to thank Chris Siebenmorgen for recommending this topic, and this topic was voted the #1 topic of interest on LinkedIn. So thank you for all who not only proposed topics, but also voted for the topics. What we'll talk about today is a little bit of background, answering some questions. For example, what is innovation and what are the broad categories of innovation? Because those are interpreted differently depending on who you're talking to. We're going to talk a little bit about Sharp2 and FHWA and how Sharp2 looked at rigid, flexible, and composite pavements and the innovations associated with those. And FHWA puts out a nice document about technology and outreach efforts. We're going to talk about a paper and presentation that John Epps gave in 2019 at Transportation Research Board that specifically looked at innovations. And that includes innovations in asphalt binders and asphalt mixtures, construction, recycling and research, management systems, and workforce. And then finally, we're going to talk about a seminar, a symposium that AAPT, the Association of Asphalt Paving Technologists, put on in March of 2021. And during the symposium, there was a lot of discussion about what the future was. And so I picked out 3 categories from that and added a little bit of information from my perspective on how to handle the data that we're collecting, environmental legislation, and then innovative materials. So let's first define innovation. What is innovation? According to Webster's New World College Dictionary, the 4th edition, innovation is something newly introduced, and it can be a method, a custom, or a device. Merriam-Webster defines innovation as a new idea, method, or device. Harvard Business Review defines innovation as a creation of new products and services. And then finally, just like students, faculty also go to Wikipedia to look things up. Wikipedia defines innovation as practical implementation of ideas that result in new goods or services or improve existing goods or services. And so all of these are dancing around the same type of questions. What is new? What is improved? And most importantly, especially in pavements, what can be implemented? Because we always need to keep an eye on what we're able to actually go and take into the field and implement to improve our roadway network. So let's take a look at some of the challenges here that we can potentially look at. So let's take a look at a technique, taking a condition survey, and what sort of challenges are associated with that, and what sort of innovations can come from those challenges. So this technique, a condition survey, the traditional condition survey is a visual survey. And the FHWA Distress Identification Manual, which you can download online for free, has a great condition survey guide, or you can look at ASTM D6433. And this is fantastic for student assignments. It is a lot of work, but it really makes people understand what are distresses and how are they identified. Now, of course, when we're talking about entire pavement networks, these types of visual surveys are often not very efficient. So we have automatic surveys. This includes automatic survey vehicles such as ARAN, Pathway Vehicles. Those are both 2 specific companies. There are more out there. But all of these are laser or camera-based type surveys where a road is scanned by a piece of equipment. There's also been some research done with cell phone gyroscopes for roughness, which we'll talk about a little later on. But these are all examples of potential automatic surveys. Now, in order to quantify distresses, the most traditional way is a pavement condition index, PCI. A little more recent is the International Roughness Index, or IRI. These are just 2 ways to take all of your distresses and combine them down into one single number. Now, a big push by FHWA in the United States that's being implemented by state DOTs is some sort of combination where, for example, for asphalt pavements, you have a combination of IRI, percent rutting, and percent cracking, or depth of rutting and percent cracking. For rigid pavements, you have IRI, faulting, fractured slabs, and punch-outs for CRCP. And what you do is you take these categories and you assign either a good, a fair, or a poor rating to each of those. And then by combining all the categories, you can say the road is in good, fair, or poor condition. So that's kind of the latest wave of innovation. And then finally, how do we predict distresses? Well, you can use historical data based on materials, design, traffic, environment. But more recently, complex models are always being developed and some have been implemented. Another concept on the horizon is the use of artificial intelligence or AI to try and predict distresses. But the point is that this is just in dealing with a condition survey and some of the possibilities that are coming out of a condition survey. So this is just one technique, and I encourage you to check out the February 16th, 2021 Pavinar, which talks about pavement management systems and has a lot of information on condition surveys. So this is one technique. Now let's look at one single product, an asphalt binder. So what are some of the challenges that we are dealing with now? What are some of possibly the innovations that can come out of them? Well, from a manufacturing perspective, asphalt binders historically have consistently come from refineries. In the past, however, refineries would produce asphalt binders as part of their portfolio of materials to sell. But now, asphalt binders tend to be almost a byproduct, an afterthought of the refining process, which has changed the asphalt binder supply greatly. And then after the refinery, we get our asphalt binder from the refinery, but they're often blended at terminals with different types of materials such as flux oils, gas oils, re-refined engine bottoms, polyphosphoric acid, polymers, chrome rubbers, that list goes on and on. And when you get into proprietary products, it gets even longer. But the point is that there are a lot of things that are being blended with the asphalt binders as well. Now, how do we quantify the performance of asphalt binders? Well, pre-1960s, we had the penetration test. From about the 60s to the 90s, we used viscosity grade here in the United States. And post-1990s, we have transitioned to the super pave binder grades for asphalt binders. And if we look just in the last 10 years at the research that's being done, a couple of tests have started to gain some traction. The multiple stress creep and recovery, or MSCR. This is a high temperature binder test, and it's represented by J sub NR. The linear amplitude sweep test, or the LAS test, this is an intermediate test, and you can see it's the number of cycles to failure, so it's a fatigue type test. And then the 4 millimeter DSR is a low temperature test, and you get M sub R and G sub T out of that. So even within the SuperPay binder grading system, there's always innovations that are occurring, always new data that's trying to be collected. And then we look at design. Of course, we have our reclaimed asphalt pavement, our RAP, our recycled asphalt shingles, our RAS. We have hot mix asphalt, we have warm mix asphalt, either in the foam, the wax, or the chemical type. We have cold mix asphalt, which can be asphalt emulsion or also asphalt foam. This is just one component of one pavement material. So we had one slide of one technique in pavements. This is one slide of one product with pavements. So if we're going to have a presentation on innovative pavement techniques and products, is this going to be a 30-minute webinar or is it going to be a 5-day seminar? Because it could be either one. And this will probably be just over 30 minutes, probably be about 40 minutes or so. But in theory, we could spend days talking about innovative pavement techniques and products because there are so many out there in flexible and in rigid pavements. And so what I decided to do is I decided to take a step back and look at some key resources and see what they thought was kind of out there on the horizon. So we'll start with Sharp2, the Strategic Highway Research Program. They put out a nice document that talks about rigid, flexible, and composite pavements. We're going to take a little look at the Federal Highway Administration, or FHWA. They looked at technology and research outreach efforts for pavements. And then John Epps, the godfather of pavements, he was invited to give the 2019 Thomas B. Dean Distinguished Lecture at Transportation Research Board, and he identified asphalt binders, asphalt mixtures, construction, recycling, research, management systems, and workforce as key areas that we need to keep our eye on. And then finally, the Association of Asphalt Paving Technologists, or AAPT. We're going to look at the Rebecca S. McDaniel Symposium on Asphalt Advancements. And remember, this was held on Wednesday, March 10th, 2021. And the three topics that I broke out from the content that was delivered that I was able to watch as data and how do we handle and manage all of that data, upcoming environmental legislation, and also innovative materials. So what do I think you should look out for during this presentation? I'm just going to give some broad coverage. I'm going to provide some key words. And if there's a topic that's interesting to you, I encourage you to write down some of those keywords and use the search engines, use TRID, the Transport Research Innovation Database, use Engineering Village if you guys have access, even just use Google and Google some of these keywords and try and find out what more you can learn about these subjects. And that goes back to the fact that is this a 30-minute presentation or a 5-day workshop? Because I really don't have the time to get into all the details, but I hope to provide you with some resources, with some key words, so that if you are interested in something, you'll be able to move forward from there. So that's a little bit of background. That has set the stage, and now we're going to move to Sharp2 and FHWA and what their perspectives are. So Sharp2, if you Google S2-R23-RW-2, you will find a report that was produced in 2014. It's called Guide to Using Existing Pavement in Place and Achieving Long Life. It was written by Jackson, Puccinelli, and Mahoney. And I'm focusing on Chapter 6, which they titled Emerging Pavement Technologies. And they talked about rigid, flexible, and composite pavements. The other national level perspective is from the FHWA. So you can Google FHWA-HIF-18-058 and you'll find a report from 2018. And this is the annual report, and it's the Accelerated Implementation and Development of Pavement Technologies, or AID-PT. This was written by Fouch, Johnson, and Ahlstrom. And basically, it talks about the technology and outreach efforts of FHWA, which includes design, construction costs, accelerated construction, new and efficient practices, pavement evaluation, and technology transfer. So Sharp2 and FHWA, let's start with Sharp2. Sharp2, when they looked at rigid pavements, they talked about ultra-thin, continuously reinforced concrete pavement, or CRCP, so ultra-thin CRCP overlays. This is first used as overlays for steel bridges. It is about 2 inches or 50 millimeters of concrete with continuous steel mesh and steel fiber. And you can see this is a cross section after a test section that was purposely failed, but it shows a very nice image of what the cross section looks like of the ultra thin CRCP. It has about 1% cross-section area of steel, which is quite a bit higher than the traditional CRCP, the full-depth CRCP, which has 0.6%. So there's a lot of steel in there. And this has been heavily researched in South Africa. Another innovative rigid pavement that Sharp2 looked at was precast concrete pavement. This isn't really very new, but it has been gaining some traction lately. It's very good for rapid construction or rehabilitation, and it can be planed or post-tensioned concrete. And here you can see a picture, and it's exactly as it is described. The concrete pavement is cast off-site into panels. It is delivered by truck to the job site, and it is simply placed on the road. And you can place about 2 to 4 panels per hour approximately. And they hope that as this is implemented in more areas, both the cost and the construction times are anticipated to drop. But just like precast concrete for structures, there's a lot of benefits to this. It's a 100% controlled environment with the casting and the curing of the concrete. You don't need to have a lane closed while that is being cast and cured. So you can just close the lane, remove the old stuff, and then drop new panels in, and you can immediately return the road to traffic. So there's some benefits to that. So those are a couple of examples for rigid pavements. What about flexible and composite? Well, Sharp2 focused on resin modified pavement, or RMP, which is semi-rigid and semi-flexible. It starts with an open graded hot mix asphalt mixture. It's about 25 to 30% air voids, and then you fill that with resin modified cement slurry grout. So here you see a picture of them paving the HMA. They pour the grout material on top, and that is that gray material that they're spreading with squeegees. And then they vibrate it into the voids. And you can see that little compactor. That's not compacting the asphalt, that's vibrating the RMP into, excuse me, it's vibrating the resin modified cement slurry grout into the open hot mix asphalt, that 25 to 30% air void hot mix asphalt. And then you cure it with a sprayed curing compound. And you can see the final product here. You have your flexible hot mix asphalt, open graded mixture, and you have your resin modified cement slurry grout placed on top. And they calculated that the cost is between hot mix asphalt and Portland cement concrete, so it's a little more expensive than hot mix asphalt. It's a little cheaper than Portland cement concrete, but they believe that you kind of get the benefits from the flexible pavement and the rigid pavement into one pavement structure. So moving on to FHWA. The FHWA report is very nice. Again, they looked at the AAPT and they have goals, and these goals will be along the left, and they have the efforts that FHWA is putting toward achieving those goals. So those efforts include a concrete clips video series, pavement design policy outreach, pavement management peer exchanges, pavement design catalog, continuous friction measurements, precast concrete pavement, long life pavement strategies, guide to sustainable pavements, construction and inspecting asphalt paving projects, and mobile technology centers. Do not worry, we will not go over all of these efforts. But I did want to point out that if you look up this report, there's a lot of good information in there. And what they did is they tied these efforts to the goals of AAPT, which is design, construction cost, accelerated construction, new efficient policies, pavement evaluation, and technology transfer. So what they did is they mapped the goals to the efforts, and this is what they found. So the different efforts achieve different goals, and the different goals can drive some of the efforts as well. So it's a very nice way to present what they're trying to do and how they're trying to achieve it. And as I mentioned, we're not going to look over all of the efforts and all of the goals. That would be part of the 5-day seminar. But we're going to focus on these four: the pavement management peer exchanges, the continuous friction measurement, the long life pavement strategies, and the guide to sustainable pavements. But if you're interested in the other ones, I encourage you to download the document. There's plenty of good reading material there. For the pavement management peer exchanges, FHWA believes the current challenge is for the pavement management system. So this includes both data quality and data quantity. Because when you are trying to collect the condition of your roadway network, you get an extremely large amount of data quantity. And if you want to make decisions based on that data, you need to use it correctly. So you need to have that data-driven decision making. And this peer exchange, what it does is it allows states to share their experiences on pavement data quality management. So what's working, what's not working, what are some of the challenges, how have they solved some of those challenges, all of those type of things. And a key part of this, as I mentioned before, is these pavement condition thresholds. And so if you recall, I talked about how FHWA is transitioning to having pavements in good, fair, and poor condition based on IRI, rutting, faulting, cracking, and PSR, where PSR is a pavement serviceability rating. And you can see here there's the various requirements for a pavement to meet. So if we take a look at a good pavement, it needs to have an IRI less than 95. The rutting needs to be less than 0.2. the faulting needs to be less than 0.1, less than 5% cracking, and the PSR needs to be greater than 4. And you can see the same for fair and poor, and then the cracking gets broken down into different types of pavement as well. The asphalt, the jointed concrete pavement, and the continuously reinforced concrete pavement. So this concept of moving toward this type of qualification and quantification system, and then having the states share with each other their experiences on trying to implement and execute this system is a big part of the pavement management peer exchange. The next thing that we'll cover from FHWA is continuous friction. So continuous friction measurement is obviously very important because the pavement surface is critical for safety. And this can be anything from the friction, the roughness, the cross slope, any sort of hydroplaning potential. But the nice thing, the good news is that yes, we have these large networks, but we can also identify critical areas. So we know that horizontal curves, the continuous friction is very important. Intersection approaches, friction is very important. And merging and weaving areas, friction is very important. Now, obviously, friction is important everywhere. However, outside of those areas, friction isn't quite as important as in a horizontal curve, an approach to an intersection, or a merging and weaving area. So you can kind of target some areas if necessary. So states have been encouraged by FHWA to develop pavement friction management programs, or PFMPs. And if you're interested in learning more about these PFMPs, I encourage you to look at their technical advisory 5040.38. So if you Google FHWA Pavement Friction Management Program 5040.38, it'll be one of the first documents that pop up. And what it does is it looks at network level friction testing. So it allows you to evaluate your entire network to understand which certain areas are in need of more attention. Currently, a very common piece of equipment to measure friction of a pavement is the locked wheel skid trailer. And there's a picture of that from, it looks like South Carolina there. And they have that little trailer in the back. They put a wheel down that drops down, it locks down, and you can measure the skid or the friction on that section of pavement. And usually every mile they drop it down for about 1 or 2 60-foot sections, and that's how they collect the data along the entire network. Now, a little more innovative is a continuous friction measurement piece of equipment, and you can see that in the lower right-hand corner. And this uses a combination of a rubber tire and a laser. So by using that combination, you're able to take measurements along your entire pavement. So this pavement friction management program, this is one of the ideas that FHWA is trying to get out there, trying to promote, and also this concept of being able to have continuous measurements across your entire network. Those kind of go hand in hand. The next topic is long life pavements that FHWA is looking into. And the reason I chose this is because this is something that's near and dear to my heart. Prevention is better than cure, and that is an unbelievably important concept in my mind for our pavement network. And FHWA has broken it down into multiple parts, and I kind of simplified it a little bit. Please take a look at the document for all of the details. But in a sense, what FHWA is saying is that we need to design and construct structurally adequate pavements. That structurally adequate pavement needs to maintain its functional performance, and in order to do that, you maintain the serviceability of pavements. And this is important. We're not addressing visible signs of deterioration. If you see the road deteriorating, you're no longer preventing distresses. So we're not addressing visible signs. We're designing a road and we're designing a network where distresses shouldn't occur. We're preventing distresses. So that's a very important mindset, and that's not a very common mindset these days on how to take care of a network. So we have a great document from FHWA for concrete pavements. If you Google FHWA-HIF-18-25, you can download the strategies for concrete pavement preservation. And this talks about all the different strategies available from overlays to resealing, slab stabilization, both partial and full depth repairs, load transfer, grinding, and grooving of pavements. Now for asphalt, I encourage you to take a look at a website, roadresource.org. This has both descriptions of the different treatments out there for fog seals, chip seals, scrub seals, slurry seals, microsurfacing, a bunch of different types of overlays, and then information on in-place recycling, both cold in-place recycling, hot in-place recycling, and full depth in-place recycling or full depth reclamation. So it has descriptions of all these treatments. I tell my students this website is literally a textbook for all of these treatments, but a very nice feature as well is they have 4 calculators where you can actually play with your pavement network and try and understand the best treatment, the right treatment for the right road at the right time. And then finally, we're going to end up with sustainable pavements from FHWA. So FHWA believes that sustainability evolves constantly. I agree with that 100%. It is a high-level strategy that evaluates human and environmental health, along with, I believe, the economic health. That should always be a part of the 3 pillars, the economic, the environmental, and the social pillars. Sustainability is context sensitive and it requires continuous improvement. So this is all the things that FHWA believes, and I am 100% behind that. Now, the National Asphalt Pavement Association, or NAPA, has developed 4 guides for asphalt. It includes a sustainability overview and sustainability specifics. It includes procuring and evaluating sustainability and how to develop a sustainability program. So if you head over to asphaltpavement.org, or if you Google any of those bullets with NAPA, N-A-P-A, you should be able to find these documents, and they're available for free. You may need to create an account. I apologize, I don't remember. I downloaded them a while ago. But the point is that they are free, they are out there, and they're excellent resources to look at sustainability through the lens of asphalt pavements. Now, if you take a look at some asphalt specific considerations in sustainability, the concept of how much energy is needed to place the pavements and the emissions associated with that, those are things that are on the horizon of interest. The materials, we can look at the mix design, the quality control, the recycling and reuse of materials and specialty mixes, specialty products in there. For the design, the concept of perpetual pavement, a lot of good work has been done out of Auburn on the concept of perpetual pavement. So if you Google Dave Timm, T-I-M-M, and perpetual pavement, there's a lot of good information out there. From a construction standpoint of asphalt pavements, the smoothness, if you use warm mix asphalt or cold mix asphalt, what's the same and what's different than traditional hot mix asphalt? The use of alternative fuels on the job site that can potentially reduce emissions and reduce the use of petroleum-based products. And then finally, noise reduction as well of construction. Then finally, in the work zone, the health and safety of the workers is paramount. And what can we do in order to increase both the health and the safety of everyone in the work zone and everyone transiting through the work zone? So these are some asphalt considerations, no fear. There is a concrete tech brief as well about sustainable pavements and concrete pavements, and you can find that by Googling FHWA HIF 16013. So this is really just a very brief overview of these 4 concepts from the FHWA. And as I mentioned, the AAPT has a lot more in that than what I went over. These are just kind of some of the highlights. If there are some things of interest, dig deeper. There's a lot of good resources out there, but hopefully this will give you some ideas moving forward. So we're going to transition away from the Sharp2 and FHWA perspectives, and we're going to move to what John Epps thought was important. So John Epps is incredible. He has had a 50-plus year career. He's had over 500 publications, and his publications are in so many different areas: soil stabilization, recycling, flexible pavement design, polymer modification, warm mix asphalt sustainability, and structural testing. His 3 degrees are from the University of California, Berkeley. So he got those in his bachelor's, master's, and PhD. And you can see those are not the traditional spacing of those degrees. He got his master's in 1 year and his PhD in 2 years. This man's incredible today. He was incredible back when he was in school. He was a professor for 32 years, split it between the University of Nevada, Reno, and Texas A&M. He worked for 10 years in the private sector at Granite Construction, and he is currently the Executive Associate Director at the Texas Transportation Institute, or TTI. So you want to talk about innovative technologies and innovative products. If we can find out a way to download all of his knowledge on a USB port or something and plug it into other people, that would be great because he's an incredible gentleman. I've had the privilege of having several conversations with him at conferences. He's very down to earth, nicest guy you can ever meet, and his data, his knowledge set is just incredible. I can't say enough about it. And Transportation Research Board recognized that as well. So he gave the 2019 Thomas B. Dean Distinguished Lecture. And in addition to the lecture itself, he also wrote a paper. The paper is titled Innovative Asphalt Pavement Technology, Paving the Way for the World's Roadways. And you can find it in the Transportation Research Record, volume 2673, the first volume, and it's pages 1 through 16. So he was the first paper in the first volume in TRR's 2019 series, and that is definitely very well deserved. And as I mentioned, he talked about asphalt binders, asphalt mixtures, construction, recycling, research, management systems, and workforce. Now, he talked about more than this as well, but these were the big ones. These, I think, had the biggest bang for their buck. But I encourage you to try and get a copy of that paper. It's a phenomenal paper. And maybe the lecture's out there on YouTube or online or something. I wasn't able to find it, but I'm sure a lot of you are more adept at using search engines than I am. So there's a lot of good opportunities out there to find out more. So let's start with the materials. Let's talk about asphalt binder. He thinks there's a lot of additives and modifiers out there, and we need to learn how to accurately categorize the behavior of those additives and modifiers to make sure that the test results are representative of what will happen in the field. He thinks that the chemical characterization of asphalt binder is a big topic moving forward. Asphalt binder is a highly complex material, a lot of carbon chains, a lot of carbon rings, a lot of different molecules and molecular structures. He thinks there's a lot of work to do looking at the chemical characterization. He thinks that not only the aging of asphalt binder needs a lot of work to understand, but also how do rejuvenators play into that. Do rejuvenators reverse aging? Do they mask aging? Do they stop aging? Those are the type of questions that need to be answered. And not only those three key questions, but also how it occurs. Like what are the actual mechanisms that are occurring? And then he also believes that there's a lot of changes in manufacturing of asphalt binder. I talked about that a little bit earlier about how the refineries are moving away from having asphalt binder as one of the kind of planned for products to where it's almost an afterthought. So changes in manufacturing and then how it's blended with other materials is very important. Now, I encourage you to Google NCHRP 9-60. This is a report about the latest and greatest with asphalt binders. And this is really on the cutting edge of asphalt binders. And it deals a lot with these topics that are listed here that Dr. Epps discussed as well. Looking at asphalt mixtures, he believes that there's something about balanced mix design that'll gain traction. That's something that we should look out for in the future. So looking at both the cracking and the rutting potential during the mix design and designing mixtures based on those cracking and rutting numbers. He thinks there's a lot of tests out there that are of high importance and need to be better understood. This includes fundamental property characterization, aging, again pops up here, water sensitivity, and any sort of performance-related tests. And he believes these tests to be suitable for a mixture design stage. They should be used for the structural design, and they should be used for quality control. And quality control is a pretty big statement right there that could deserve a slide on its own. I didn't break it out, but this concept of quality control, quality assurance, agency assurance, that's something that's definitely coming up on the horizon. And then finally, he also thinks there's a lot of opportunities to look at mixtures for low traffic volume roadways. Low traffic, low traffic volume roadways are the highest lane miles of roads by far in our networks, and they get by far the least amount of money, and that's because there's not a lot of traffic on them. But if we can really start addressing how to design high quality, long lasting roads for these low traffic volume roadways, that could really go a long way in taking care of our networks. Now, asphalt mixtures, you could look at cracking, you could look at rutting, you could look at aging, you could look at moisture sensitivity, all sorts of different things. If you just want to look at cracking of asphalt mixtures, take a look at NCHRP 9-57, because that looked at all of the current innovative tests for asphalt concrete cracking, just cracking. So NCHRP 9-60 for binders, NCHRP 9-57 for mixtures. Those are 250, 200 pages reports that will give you more than enough information on those topics. Very well done documents, and both are available online for free. You do need to enter an email address, but you can log in as a guest and download them for free. So I encourage you to take a look at that. Next, we'll look at some construction innovation that Dr. Epps talked about. He thinks that GPS technology, global position system technology, is something that's on the horizon because that has a lot to do with autonomous and connected vehicles. And these autonomous and connected vehicles could be either on the construction site or it could be managing these vehicles as passenger vehicles as they go through construction sites. So that's kind of a two different perspectives you can look at. You can either look at the construction itself or vehicles passing through the construction site. He also thinks that there's a lot of opportunities for accelerated construction operations. This includes contracting methods, traffic management, work zone safety, materials, construction operations and equipment, and the economics behind it. There's a lot of things here that we could start looking at. And again, he goes into some more details in his paper, but these are things that are on the horizon with construction innovation, according to Dr. Epps's perspective. He thinks that there's a lot of opportunities for innovation in recycling as we increase and continue to use RAP, reclaimed asphalt pavement, and RAS, recycled asphalt shingles. We're going to need to think about how that influences the asphalt binder and if we need to add different modifiers into the asphalt binder to account for that. The whole point of using RAP and RAS is to take the asphalt binder out of those materials and utilize them in new asphalt mixtures. But you often need some sort of modifiers in order to have that happen. He also thinks there's a lot of opportunities for mixed design for cold recycling, both cold in-place recycling or CIR, and you can see a picture of that on the right, or CCPR, cold central plant recycling, which is essentially like where you use a traditional hot mix asphalt plant, sort of, but instead of putting hot asphalt binder in and heating all the asphalt up, you put asphalt emulsion in and you do not need to heat the aggregate up to the high temperatures. And he also thinks that there's a lot of opportunities for innovation in recycling construction equipment as well. A lot of the equipment that we're using is decades old, and there are opportunities for innovation and advancements there. Research innovation. This is probably the best slide of the presentation. As an academic, I'm always interested in more research. He thinks that we need more performance-related tests and specifications. We need more accelerated testing facilities. I cannot argue with either one of those. He thinks we need more long-term pavement performance projects. So he referenced the Sharp LTPP program, the long-term pavement performance program. And this is a great program. They've been collecting data for decades now, and he thinks we need more of this in more areas than what Sharp had looked at, because Sharp had relatively narrow scope. There's a lot of other things that we could track. He thinks we need to spend more time contemplating this concept where very small performance improvements can have extremely large benefit cost ratios. And very small reductions in initial costs can also have very large benefit cost ratios. So we don't need to necessarily solve all the world's problems in one project. He thinks there's something to be said for small steps. Over time, not only do those small steps build into big steps, but because of the scale of what we're working on, if we can just make one small performance improvement, or if we can just make one small reduction in initial cost, if we apply that across the entire pavement network in the United States, if we apply that to the entire pavement network across the world, we can see extremely large benefit cost ratios. So he's warning us, you don't always have to hit a home run with your research. Sometimes those small incremental steps can be just as valuable. He thinks that local governments need to step up and play a larger role because, as I mentioned before, the local governments, those have all of the smaller, usually two-lane highways, very low traffic volume, but very high lane miles. These provide unique challenges, but they also provide unique opportunities. And then finally, he believes that we need to make sure that the public and private sector research is not only occurring, but it is occurring to advance the knowledge in order to improve all roads and not, for example, in the private sector, just to promote one product. But also the public sector does need to recognize the value of research and continue to fund research um, in order to advance their knowledge. And then finally, he thinks that universities need to take a look at themselves. And this is something that someone who's had a 50-plus year career can say in front of a room full of people who fund research and lead universities. But he thinks that faculty need more than just the latest and greatest. So right now, faculty are essentially, we are graded on how much money we bring in, how much publications we put out, and how many PhDs we graduate. Those are very, very high on the weighted scale. And in order to do that, we often need to look at what is the latest and greatest. We need to take that next step. We need to keep on moving forward quickly. But this kind of goes back to this concept of his small performance improvements and small reduction in initial costs. Because yes, the latest and greatest is important, but he also believes we need a contribution to society component. So how are we helping society? Is our best idea, is our latest, greatest idea, is it going to help society or is it going to help our careers? And he thinks that universities need to weight contribution to society a little more strongly than it's being done now. Lots of great information here, and I got to say it, I'm sorry, people are going to roll their eyes, but more research is needed. And of course, an academic's going to say that, but there is a lot of opportunities here, and we need to continue moving forward. So the next topic that Dr. Epps talked about was management systems and innovations around management systems. He thinks that we need to continue to work toward and improve our automated data collection equipment, and we need to understand how to use those large data sizes that we get out of that data collection equipment. We need to make sure that we're using the information at various organizational levels. So all organization levels in agencies and companies and universities, we need to make sure that we're getting the data that they need, the information that we need to get to them in order to make the right decisions. So upper administration needs to recognize the value of research, the value of recycling, the value of construction innovation, all those type of things in order to allocate resources to that. And then as you go down the management systems, the management layers, they need to recognize that yes, you need to take care of the day-to-day operations, but you also have to have an eye in the future, and you need to allocate resources to that. And then the workers, the lower levels, they're the ones who need to actually then implement these ideas and do the actual work. And so recognize that yes, you do need to do the repetitive work, you do need to check the boxes, but also what can we be doing to continuously move forward? What are some of those small increments that we can do? And then finally, he also is keenly aware of rapid sampling and testing methods. Construction crews, the one thing they never want to do is stop. Construction crews always want to be moving. And so we need to recognize if there's a problem. And we need to recognize quickly if there's a problem with what's being put down. So you not only need rapid sampling, but you also need rapid testing. So if there is a problem, you can identify it, you can change it, and you don't spend a whole day paving a mediocre product. Then for workforce innovation, he believes in the importance of training programs for the next generation of learners and the continuing effort. And a big part of this in his discussion is this concept that a lot of people these days don't want to sit in a room for 3 days and have 8 hours of PowerPoints thrown at them. They want something that's flexible. They want something that's on demand. They want something that's online. So when they need it, the worker needs it, they can look at it, they can access it, they can get what they need, and they can move on. And it's amazing. Everyone is walking around with a smartphone. So there's no reason why we can't implement this. So lots of opportunities for workforce innovation, and it's a continuing effort. It's not something that we're going to solve today. So these are just some ideas from Dr. Epps' perspectives, and I encourage you to take a look at that TRR paper and read it through. It's a joy to read, an excellent document, so I hope that you take the time to do that. But now we're going to pivot away from Dr. Epps' perspective and move to the 2021 Symposium. And just like Dr. Epps, I'm going to give a shout out to Becky McDaniel. This was put on by the Association of Asphalt Paving Technologists, and it was called the Rebecca S. McDaniel Symposium on Asphalt Advancements. And Becky, or Dr. McDaniel, had a 35 plus year career. She passed away in May 2020, and a group of people with AAPT got together and said, she deserves a symposium. We need to remember her and talk about all the great things that she did and all the great things that we're doing. Dr. McDaniel got her degrees from Purdue University, her PhD and her MS, and she got her bachelor's from Indiana University. She worked with the Indiana DOT for 10 years as a research engineer, and she worked for over 20 years as the technical director for the North Central Superpave Center. She served on the board of directors for ASTM International and was a past president of AAPT. So just like Dr. Epps, the accolades could go on for Dr. McDaniels. But I would like to give a shout out for her excellent taste in Indian restaurants. I had the distinct pleasure of visiting the North Central Superpave Center. While I was in West Lafayette, I was visiting Purdue as well. And Dr. McDaniel was gracious enough to take me out to lunch, and we had an Indian lunch. And anyone who knows me, the easiest way to get to my heart is through food. And she drove right there and she took me to an Indian restaurant, and it was phenomenal. So, a very good memory of a lunch with her. This was held on Wednesday, March 10th, 2021. And I think there were 8 or 9 presentations. Well, it started with a very nice 30-minute reflection on uh, Dr. McDaniel's contributions to our society, to asphalt pavements, to our lives. It was a very nice discussion. But then there were various presentations put on by the best and the brightest in our industry, and I extracted 3 different topics from that. I thought that these really reflected what was going on. And the first is data, the second is environmental legislation, and the third is innovative materials. And there are some familiar concepts, there are some new concepts. So if you've been around the industry, you'll recognize some things, but hopefully there'll be some new things as well. And I was looking at 3 presentations in particular that created the foundation of this content, but I also added some of my own content as well. So I'm going to give a shout out to the presenters, but I do want to recognize that there's some information that I added as well. They kind of provided the foundation, the idea, a lot of the content, and then I added some things as well. So the first one on data, this is from John Harvey. He's a professor at UC Davis. And he talked about data from a pavement network level perspective. And condition surveys are mainly collected by machine data now. He believes that something that's coming out on the horizon is the use of artificial intelligence and using artificial intelligence to try and predict distresses before they occur. So we're collecting all this data. Why don't we put AI to use and say, and try and recognize when distresses are going to occur before they occur so we can be a little more preventative rather than reactive with our decisions. Another thing he pointed out was that most manuals for condition surveys were written for human data collection. So they're written from the perspective that a human would be collecting the data. So he spent a lot of time with Caltrans trying to write new manuals that reflect the fact that most data is now collected by machines. So we want to write these manuals based on the fact that a machine will be collecting the data, not a human. He spent some time also talking about crowdsourcing data. So as I mentioned, everyone's got a phone. Everyone's driving the roads. Why don't we use the public to report issues and concerns? So there's apps out there saying if you see a pothole, click a button. And then the agency will know exactly where that pothole is. And the more buttons that are pushed for that pothole, the more severe that pothole is. So they'll be able to fix that. So why don't we start using some of the people who are driving our roads to help us collect the data that's needed? Now, there's also this idea of using cell phones for pavement roughness, and I was really excited about this because last fall during class, one of my students, her father owns a construction company, and he was driving a dump truck, and she was riding along in the passenger side. And it was funny because she was taking a video of this ride, and you could tell the phone was visibly shaking because one, it was a bad road, and two, you're in this gigantic truck that has the comfort of a wagon, so like a horse-drawn wagon. So she emailed me and asked me, has anyone ever looked at using a cell phone to measure pavement roughness? Because you could see her cell phone was moving, and cell phones have gyroscopes. Well, I was so excited because one, a student was thinking about pavements outside of class. That in itself is an honor and something that's exciting. And two, she wanted to learn more. So, I mean, it was just one of those emails that make our job worth it. And so I did some digging, and the University of Illinois with Bill Butler did some work at using a cell phone and trying to compare cell phone data to a traditional IRI profiler. And this is from Islam et al. It was a TRR paper published in 2014. But you can see here with the calibration factor, there's actually a pretty decent relationship between cell phone IRI and a traditional IRI profiler. So that's a great paper. I'm not going to get into that anymore, but people have tried to use cell phones in order to quantify pavement roughness. And then finally, Dr. Harvey was looking at smart pavements as well, perhaps using some instrumentation in the pavement in order to collect data about distresses and how those distresses are formed. He asked the question, could pavements be used to conduit wireless data? We're a connected world now, and could we use the pavement somehow to transmit data? Because cars are running over them, people have their cell phones. What if the road itself is the conduit of that wireless data? And then finally, he does recognize that these smart pavements are more expensive, so he thinks it's very important to ask, do the benefits outweigh the higher costs? So lots of points to ponder here about data and data collection. Now, Dr. Jeff Rowe from AAPT talked a little bit about the environment and legislation from agencies, the public agencies coming down. For example, the International Maritime Organization, or IMO 2020, passed very significant legislation about reducing sulfur emissions, and they are requiring ships to reduce sulfur by 80%. Now, you may ask, why on earth does a pavement preservation or a pavement presentation, why are they interested in the International Maritime Organization? Well, it's because so many of our raw materials are shipped by boats. So if boats are required to reduce sulfur emission, it's going to be more expensive to ship road materials. If it's more expensive to ship road materials, the price of road materials will increase. Now, so Dr. Rowe talked a lot about that perspective, but I asked this other perspective. If the International Maritime Organization is interested in reducing sulfur emission, what parts of pavement material extraction, material production, then the either asphalt concrete or Portland cement concrete production, the construction, there are all sorts of opportunities to reduce emissions in all stages of the pavement life cycle. So what if an organization begins to start implementing those? And in a way, they already have. So Caltrans has been very active with environmental product declarations, or EPDs. And I think of EPDs as a safety data sheet, or an SDS, for the environment. So basically, you look at the side of a cereal box, and there are the list of ingredients and the calories, all that type of things. An EPD is basically that little data set right there, but it's based on the environment. So what sort of emissions are emitted by products? What sort of emissions, what sort of wastes, how much water is used, those type of things, all these environmental considerations, but for different products. And in 2019 and 2020, Caltrans did some pilot projects with road materials, with hot mix asphalt and with Portland cement concrete. So this is something that's coming. And Caltrans, if they start implementing it, isn't, I think California is like the fourth largest economy in the world. If Caltrans starts implementing this, this is going to start bleeding into other states. And so this is something that we need to keep an eye out for, is uh, either national or even state agencies having environmental guidelines that need to be followed. Now, I just touched on this, but if you go to the Pavinar YouTube channel and you go to the playlist, the Andrew Braham presentations, one of the presentations I gave on March 5th was the need for EPDs. And so you can find out a little bit more about that if you're interested. So go to the Pavinar YouTube channel, go to Andrew Braham presentations, and one of those is the need for EPDs, and you can learn a lot more about EPDs, or environmental product declarations. And then Dr. Amy Epps Martin and Dr. Randy West from Texas A&M and NCAT respectively talked about innovative materials. So they talked about reclaimed asphalt pavement and recycled asphalt shingles, not only those materials themselves, but also the recycling agents and rejuvenators that may need to be used with those materials. They talked about the use of waste plastics, both the dry and the wet process. They talked about re-refined engine oil bottoms, or REOB, being used in asphalt binders. They talked about the use of recycled tire rubber in asphalt concrete, both a dry and a wet process. They talked about various fibers in asphalt pavements. And if you're interested in learning more about fibers, I encourage you to take a look at the NCHRP Synthesis 475. That synthesis talks about cellulose, mineral fibers, synthetic polymers, plant-based fibers, glass fibers, waste and recycled fibers, and other sorts of information. And then finally, bioasphalt, either from animal waste, plant-based bioasphalt, or even algae. These are all potentially new supplements, complements, or replacements for traditional asphalt binder. So lots of information going on, and this list goes on and on. But if you're interested in any one of these particulars, there's a lot of information out there, so I encourage you to pursue that. So we covered a lot of ground. That was more than 30 minutes, I apologize, but we covered a lot of ground. We did a background of innovation, what Sharp2 and FHWA, what Dr. John Epps thought about innovation, and then some thoughts from AAPT. We covered a wide range of topics, and again, I hope that this will give you some ideas, some keywords to look at in the future, so you can dig deeper into certain areas of interest. But if you made it this far, thank you very much for joining me, and I hope you have a wonderful day.